Hi, Mr. Trutna, talking to you about the notes for Unit 4, assignment number 2. So the first thing is, if you were absent on, it'd be Tuesday, November 15th, then you probably want to pause the video and you want to take a moment to get this information down. These are the notes that we went over in class. Obviously, you're going to be missing all of the dialogue that we had, but it's better than nothing, right? Okay, so let's finish off the notes here for showing two triangles are similar and then solving for a missing side in similar triangles. Okay, so let's just suppose that I give you a shape that looks like this. And in this particular shape, there are two distinct triangles that you see, as you can see right there. And let's put some letters at every corner of the triangle so we could distinguish what we're talking about. So the triangle on the left has an A, a B, and a C in it. And the triangle on the right has an X, a Y, and a C in it. And then in the picture, you see these arrows that are right here. Okay, and then the question is, are these triangles similar to each other? So what we're going to be answering in this is triangle ABC similar to triangle YXC? Okay, that's what we're going to be answering. Okay? Now, how do you know if triangles are similar? Well, the fact that they have parallel lines does not make the triangles similar. Okay, remember, in order for triangles to be similar, one of three rules has to apply. Either the AA rule, the angle-angle rule, has to apply, the side-side-side rule has to apply, or the side-angle-side rule has to apply. All right, so let's go through here and let's mark any pieces of triangle ABC that we are 100% positive have to be congruent to any part of triangle YXC. And you hopefully see right away that the triangle right in the middle between the two, or the two angles right in the middle of the two triangles, are congruent because of parallel or vertical angles. Okay, so that right there just gave us a pair of equal angles. Okay, that's what the A stands for in these rules, a pair of equal angles. Okay, now hopefully you also notice that because the lines are parallel, that means that angle A has to be equal to angle Y. And the reason why those are equal is because angle A and angle Y are what we call alternate interior angles. And alternate interior angles are equal when we have parallel lines. So that just gave us another pair of equal angles. So the answer is yes. Is triangle ABC similar to triangle YXC? The answer is yes. Okay, and let's go ahead and let's put this in a let's write this out and show the triangles are similar in a flowchart manner. Okay, now this flowchart manner is going to have four ovals in it. It's going to have an oval for the given parallel lines. It's going to have an oval for the vertical angles. It's going to have an oval for the alternate interior angles. And then it's going to have an oval for the final part that says the triangles are similar to one another. Okay, so this top oval right here, we would write that A to B, side A to B, is parallel with side Y to X. And we know that because that was given to me with those red arrows. Okay, now, because A to B was parallel with Y to X, that now told me that angle A, and I have to put the angle symbol to name angle A, is congruent to angle Y, and those two are congruent because of the alternate interior angle rule, AIA. Okay? Now, that oval is going to lead to my final oval, as is that one right there. Now, in this third oval over here, we know that angle C is congruent with angle C, but we can't say C and C. We have to use 3 letters. So the angle on the left here, the vertical angle on the left, we're going to call that angle ACB. We know that angle ACB is congruent with angle, and we'll name this one as YCX. We have to name it as angle YCX. And those are congruent because of vertical angles. Vertical angles are always equal to one another. Okay, and then what this does is because we have 2 pairs of congruent angles, this tells me that triangle ABC is similar with triangle YXC. And that would be the angle similar rule. That makes them similar. Okay, so you guys, that would be an idea of how to show 2 triangles are similar and how to put it in a flowchart proof. Okay, so now let me add some more information to your diagram here. So let's say in the diagram I tell you that side A to C has a length of 18, and side B to C has a length of 22, and side X to C, or C to X, has a length represented by the algebraic expression x plus 2, and then side Y to C is represented by the algebra expression just x. Okay, and then what I want to do is I'm going to go over here. I'm going to solve for x, the missing side, in these similar triangles. Okay, so if you notice in this triangle, side A to C, because the letters A and C in my similarity statement down here are the first and the third letter, that means that's going to match up with Y and C, the first and the third letter. So that tells me that I have a fraction 18 over x. Whenever triangles are similar and you're solving for a missing piece, an x, you always want to write 2 fractions. I'm going to write a second fraction, and then you cross multiply. Okay, going back to triangle ABC, 22 is B to C. If you notice over here, B and C are the second and the third letter, so that has to match up with X and C right there, which is X plus 2. So my other fraction, or my ratio, is going to be 22 over X plus 2, and then to solve this, I cross multiply, and then I solve for X. So I'm going to multiply the 22 with the X, which is 22x, and then I'm going to multiply the 18 with the x plus 2, which is 18x plus 36. What I did right there when I multiplied the 18 with the x plus 2, you can see that I distributed 18 times x, 18x, plus 18 times 2, 36. When you cross multiply, the 2 results are equal, and I solve this equation. Subtracting 18x from both sides, my new equation becomes 4x is equal to 36. Those 18s will cancel. I divide both sides by 4. X is equal to 9. Okay. All right, guys. Work hard on your homework. Ask questions. Be excellent. Make good choices.